So here we have our circle R, and we have a rectangle MNPQ inscribed in the circle. So here's the center. Here's our rectangle inscribed. Notice how each of the vertices is on the circumference of the circle. Inscribed. Okay, let's take a look at a couple of our givens. We know arc MN is 120 degrees, so let's label that in our picture. And let's think about what else we know based on that given. So here this arc is 120 degrees. We can see that it's an intercepted arc for our angle MRN. The vertex is at the center of the circle. That's a central angle. And we know the central angle is the same as the arc measurement that it intercepts. So if this is 120, the angle is 120. We also have a vertical angle here for QRP, which is also going to be 120 degrees. So we have those. Then we can see we have some linear pairs here. So that would be a total of 180 degrees. If we used up 120, that means this angle is 60. Also, MP is a diameter for our circle. So if there's 360 degrees around, the diameter is going to cut it in half. It's 180. Same idea, 180 minus 120, that would be 60. So we have 60 degrees here for the angle, the central angle, which is the same as the measurement of the arc, 60 degrees. And 180 minus 120 would be your 60 degrees. And again, we'll have vertical angles here, so we've got another 60 degrees. And then the intercepted arc, again, here would be 60 degrees as well. So we have a good start labeling our picture based on that one given and using our properties. For central angles being the same as the arc measurement, we had some vertical angles, congruent, and so on. So let's now start working on finding some of these angles, these inscribed angles. Remember, that means the angle is on our circumference of the circle. So let's take a look at our angle 1. So angle 1 is an inscribed angle, vertex on the circle. Now if we look at the sides, it has an intercepted arc. Here, this intercepted arc is 60 degrees. Well, we know that the inscribed angle is always half its intercepted arc. So this is 60, half of that would have to be 30 degrees. Now we're moving on to angle 2. So again, an inscribed angle, the vertex is on the circle. And let's see what intercepted arc it cuts off. That's 120 degrees. The inscribed angle is always half the intercepted arc, so half of 120 would be 60. So if we look at our angle for 3, it's an inscribed angle. Its intercepted arc is 120. The inscribed angle is always half the intercepted arc, which means that has to be 60 degrees. Looking at our angle 4, again it's an inscribed angle. Let's see what intercepted arc it has. That would be 60 degrees, so half that arc is the angle, so half of 60 would be 30. Then going on to angle 5, an inscribed angle, the vertex is on the circle. We're looking at the intercepted arc. It's 60 degrees, so half the intercepted arc represents the angle, which would be 30 degrees. For angle 6, again, an intercepted arc that it has, it's 120 degrees. The angle should be half the amount, which would be 60. Angle 7, another inscribed angle, seeing what kind of arc it intercepts. QP right here, 120. So remember, the angle is half the intercepted arc, which means it would be 60 degrees. Then our angle 8, another inscribed angle, the vertex is on your circle. The intercepted arc it has is 60 degrees. Half of that amount should represent the angle measurement, so half of your 60 would give you your 30.